What we're saying here is that a particle of mass 8 kilograms lies on a rough plane inclined 30 degrees to the horizontal. Coefficient of friction between the particle and the plane, that'll be this part here, this plane here, is 1 over root 3. If the 8 kilogram mass is connected by a light inextensible string passing over a smooth light pulley at the top of the plane to the pulley of mass 2 kilograms hanging freely. Over this pulley, which is also smooth, a second light inextensible string is placed having a mass of 3 kilograms and 5 kilograms attached. Show in separate diagrams the forces acting on each of these masses when the system is released from rest. Show that the acceleration of the 8 kilogram mass is 3 over 35 g. Okie dokes. So, keyword there is plane. That word there, plane, it means that the triangle here cannot move. If it's a wedge, it can move. If it's a plane, it can't move. Next thing is we're going to just draw in a couple of tensions here. We call that T1, T1, then T2, T2, 3G, 5G, 2G. Reaction force R, where friction equals friction equals mu R. Is that alright? So let's do what we always do. We compare to the 8 kilogram particle and we draw our white triangle. So it goes down at 8G and dot 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 dot. Okay guys, so what we have here is 30 degrees, so 8G cos 30 and 8G sine 30. I'm pretty sure 8 cos 30 is 4 root 3, is that right? Root 3 over 2, so 4 root 3G. And what's the other one? 4G. Thank you. 4 root 3G, and the other one is 4G, because sine 30 is a half, so just half 8G, and you get a 4G. Okay, going down, around, R. Now, we haven't specified our accelerations yet. Now, if you did this, if you said, I think it's going to go downhill, I think that's going to accelerate upwards, and then obviously the 5 will go down relative to the 2, and this will go up. That system's correct, and you should still get the same answer. Is that alright? So look, what I'll do here is I'll follow through. I've seen the solution already. The solution has done completely different. I'm going to follow through with us just completely thinking a different way of doing it, and let's see if it works out anyway. Is that right? So let's find out. So we sort of said, to be honest, because it's a silly assumption, because most of the weight, the 8 kilograms, not hanging freely. So in comparison to how many kilograms? 10 kilograms. So I think everybody's pointing that the opposite direction, okay? But sometimes it can be much closer, and you might just follow through on what you said, and it'll work out. So look, we'll just stay the same, because nobody would say that. Okay. Now, this is going up at acceleration A. What's bringing it up? T1 is forcing it up. Is there anything opposing the motion? The 4G down here, and now we're going to do friction as well. Friction equals mu R, and that is going to be 1 over root 3 is the coefficient of friction, multiply by, what's R, guys? Because see the way it's balanced, see the way it's not sinking into the plane. The R going upwards is balanced by the 4 root 3 going downwards. Okay? So, and remember, it's a plane, it's not a wedge, so there's no no acceleration to put in beside that to fix it. Okay, so what we're looking at here then, guys, is we're looking at times 4 root 3g. Now that works out quite conveniently. Our surds are just gone now, and we're going to be left with just 4g, which is reasonably handy. Now, the 8 kilogram mass. So guys, the 8 kilogram mass, we're going to start with F equals ma. Okay, somebody start me off. A is going this direction, F is going this direction. What leads? What starts the whole equation off? T1, dragging it up to the right. Minus 4g for the weight, minus. There's another 4g there. Just one for the friction and one for the weight. Totaling up 8g total. And then what about MA here? 8A, good man. And then T1 minus 8G equals 8A. And there we go. So that is first equation there. We'll just box it down here. Now, the next thing, guys, is the pulley. We'll draw the pulley in isolation. Okay, so the pulley here is going to be 2. So it's 2g going downwards. And then what forces does it have on it? Anybody tell me? The forces at play? T1 upwards and T2 is going downwards. So we call this the 2 kg pulley. Once again, F equals ma. In this case, we're saying that it's going down at acceleration a, right? So downwards and downwards, and what we're going to get is what is it? It's 2t2 minus t1, 2t going downwards, t1 going upwards, driving the overall mass, which is 2, by its acceleration. I did forget to add the 2g, you're right. So 2t2, I forgot to add the mg, 2g going downwards. It's just one little mistake of that, one little thing you forget to put in, and that's it. And t1 equals 2a. Is that the one, yeah? Okay. So, there we go. Corner that one off. Go again. Now, what we're looking at next, guys, is the what's it, the 2, the 3, and the 5. Okay. So, what is the acceleration of? What's the overall acceleration of the 3 kilogram mass? What's its acceleration? Can you see that? That's a B there and an A there. You go with B minus A. If you're using B minus A, is that up or down? Okay, so if you use B minus A, it's going up. If you use A minus B, you're going to lead with the downs. Okay, so F equals ma. Now, what force is dragging your 3 kilogram particle upwards? Or your T2? What drags it downwards? Your 3g. And then your mass is 3. What's the acceleration? Acceleration, anybody? I have a setup for B minus A. See the way I led with T2? That means up, over, up, overall up, okay? Even if that's false. So that means up leads down. You can see the symmetry in it, can't you? Force up, take away force down, acceleration up, take away acceleration down. Okay, you got to keep it like that. Now, that is yet another one. And it will go down here. Now finally, what we have next is the 5 kilogram one. So 5 kg mass. So guys, what about this one here? Anybody? What's its acceleration? Its acceleration? A plus B. Going down. F equals ma. Now, going down. So F is what, guys? 5g minus T2 equals ma. 5 bracket A plus B. And then multiply it out. 5g minus T2 equals 5a plus 5b. Okay. And then T2. I'm just going to make a list below in red. So T1 minus 8g. Yeah, I'll just rearrange that for a second. First one is T1 equals 8g plus 8a. And then the next one, which is this one here, T2 equals 5g minus 5a minus 5b. Okay, the one after that, this one here, that would be 3b minus 3a. Bring that over to the other side. Then we have another T2 equals there you go, 3b minus 3a plus 3g. And then we have this one here. Okay, we can actually see that it's actually the same procedure repeated over and over and over again now. Get T2 on its own, put them equal to each other, find the simultaneous equation of tension. Then you put T1 and T2 into the big one here. You also make a simultaneous equation, and then you wrap it up. Okay, so we'll just finish it off for completion's sake. We're going to get 5g minus 5a minus 5b equals 3b minus 3a plus 3g. Move the 3a over the other side, it's going to be minus 2a. Move the 3b over the other side, it's going to be minus 8b. Bring the 5g over to the other side, it's going to be minus 2g. Divide by 2 and multiply by minus 1, so divide by minus 2. And you get a plus 4b equals g. That's the first equation you have without t in it. Okay, one part of this simultaneous equation. Now I'm going to take this equation here, and I'm going to input T1 and T2 into it. So it says 2T2, so I'm going to multiply this one here by 2. So I'm going to get 6b minus 6a plus 6g, multiplying by 2, then add on the 2g, and then after that, guys, take away T1. So take away T1 is minus 8g minus 8a. The whole thing equals 2a. Then have a look, count up your, bring it over to 2a. So I'm going to have minus 6. Minus 6 minus 8 is minus 14. Minus 14 minus another 2. Minus 16a. Then 6b on its own. And then it's just a matter of counting the g's. 8g minus 8g is 0. So, and then we can divide all that by 2. Minus 8a plus 3b equals 0. Does the question state that I'm looking for a and b, or does it just want a? Or what does it want? Let's go back to the very top. Acceleration up to 8 kilogram mass. Have to find out what a is. So to find out what a is, it's quite easy. Multiply the bottom. Ooh, yeah. So to find out what a is, multiply the top one by minus 4, bottom one by 3. 32a plus 9b. Is that right? Oh no, sorry, 12b minus 12b equals 0. 3a plus 12b equals 3g. And there's my 35a. equals 3g, A equals 3 over 35g.